Quantitative data is quantitative data is research that is presented in the form of numerical data and quantities, which can be put into categories, rank order, or measured in units of measurement. This type of data can be used to construct graphs and tables of raw data. The main ways of gathering quantitative data is through experiments, observations, and questionnaires. There are many benefits of using quantitative data analysis. Firstly, you're able to compare it to normative data, which is data that has been compiled against thousands of studies. It is very beneficial because if you are studying the sit-and-reach test on 12-year-old gymnastics in the UK, you can compete their scores to the rest of the population's averages to see if you're above or below average. Another benefit of using quantitative data is that you can make predictions on sport performance. For example, if you have a graph on all the best gymnast routines within the UK from the last 5 years, this will give you an idea on the level you have to be at to compete in the next year and the years to follow. Finally, quantitative data allows you to identify trends in health, which refers to any number data that is associated with somebody's health within a sport rather than sporting performance. For example, it enables you to see the average resting heart rate of young British female gymnasts. Data organization. There are 4 stages of analyzing quantitative data that I'm going to be researching. The first stage is organizing data. Organizing data consists of different parts which are range, rank order distribution, simple frequency distribution, and group frequency distribution. Here are range and group frequency distribution. Range is the difference between the biggest and the lowest number. To find the range, you have to subtract the lowest number from the biggest number. The range is useful to find because it shows a sense of dispersion and variation in the results. For example, if the range is low, the performers are at a similar level, and if the range is high, then the performers are at a different level at different levels. Group frequency distribution is similar to simple frequency distribution. Apart from one column has raw data groups of scores and the other has frequency scores. There are usually between 10 and 20 groups of scores, ideally 15, and the group intervals are calculated by range divided by 15. Rank order distribution and simple frequency distribution. Simple frequency distribution is used to organize smaller data sets. When the number of cases being studied is small, it is hard to list them separately because the list would be too long. One column has raw data scores and the other has frequency scores, e.g. the number of times that specific score was achieved. And simple frequency histograms. Histograms is an accurate and precise representation of the distribution of numerical data, and the purpose of a histogram is to graphically summarize and display the distribution of a processed dataset. Usually in histograms, the independent variable is plotted along the x-axis and the dependent variable is plotted along the y-axis. To construct a histogram, you have to get all of your results and divide the entire range of your results into a series of intervals where you should then count each interval. A box plot and whiskers. A box plot is a way of representing statistical data on a plot. The plot is rectangle so that it is easy to represent the second and third quartiles, usually with a vertical line inside to indicate the median value. The lower and upper quartiles are shown as horizontal lines either side of the rectangle. The median, the middle quartile, marks the midpoint of the data and is shown by the line that divides the box into 2 parts. The interquartile range is the middle box, which represents the middle 50% of scores for the group. The range of scores from the lower to upper quartile is referred to as the interquartile range. The upper quartile is the 75% of the scores that fall below the upper quartile. The lower quartile is the 25% of scores that fall below the lower quartile. Box plots may also have lines extending from them vertically, which are known as the whiskers, indicating that the variability of the outside and lower quartiles. A scatter plot is a chart which shows the values of two variables that are plotted alongside two axes. The pattern of the consequential points reveal any correlation in existence. Scatter plots are used to show how much one variable is affected by another. The relationship between two variables is called their correlation within scatter graphs. A line chart or a line graph is a type of chart which displays information as a series of data points called markers connected by straight line segments. Line graph consists of a horizontal x-axis and a vertical y-axis. Line graphs are used to track changes over short and long periods of time. A bar chart is a chart that uses bars to show constraints between categories of data. A bar chart consists of bars that are either horizontal or vertical. Bar charts are used to show and compare the number, frequency, or other measurements for different categories of data. Standard deviation and normal deviation. Standard deviation is a quantity expressing by how much the members of a group differ from the mean value. Standard error bars are graphs that contain lines through different points on a graph and are parallel to one of the axes, which represents the variation of the corresponding coordinate of the point. When observing different data sets within standard deviation bars and there is an overlap, it is likely that there is a significant difference between the data, and therefore they are quite similar. However, if the standard deviation bars don't overlap much, it shows that the mean of the two data sets are different. Furthermore, if the standard deviation bars are totally different, it's likely there's an even bigger significant difference. Normal distribution curve is a curved graph that is symmetrical and bell-shaped. The characteristics of a normal distribution curve are that the area under the normal curve is equal to 1.0. Normal distributions are denser in the center and less dense in the tails. They are defined by two parameters, the mean and the standard deviation. 68% of the area of normal distribution is within one standard deviation of the mean. 90% of the data falls within the two standard deviations of the mean. And 99.7% of the data falls within the three standard deviations of the mean. Normal distributions are measured by subtracting the mean and dividing by the standard deviation. Outliers. Outlier is a data point that significantly differs from the other data points in a sample. Outliers are data points that differ greatly from the trend expressed by the other values in a dataset. In other words, they lie outside the other values. It is usually to detect this. It's easy to detect this on data tables or graphs. To calculate the outlier, you need to find the inner fences of your data set. First, multiply the interquartile range by 1.5, then add the result to the third quartile and subtract it from the first quartile. The same thing is done for the outer fences, except that the interquartile range is multiplied by 3 instead of 1.5. The result is then added to the third quartile and subtracted from the first quartile to find the upper and lower boundaries of the outer fence. Distribution that is skewed right is greater than the median. Also, the tail of the distribution on the right side is longer than on the left side. When data are skewed left, the mean is smaller than the median.